We want to express 3 sin x plus cos x in the form r sin x plus alpha. Let's first consider r sin x plus alpha. Using the compound angle formula for sin a plus b, we can expand this to give r sin x times cos alpha plus cos x times sin alpha. And then expanding this bracket, we get r cos alpha times sin x and r sin alpha times cos x. If we then compare this expression with this expression, we can see the coefficient of sin x here is 3, and here it's r times cos alpha. It follows that r cos alpha must be equal to 3. Comparing the coefficient of cos x, we can see it's 1 here and r sin alpha here, so we must have that r sin alpha is equal to 1. We have here a pair of simultaneous equations which we can solve to find the values of r and alpha. There are several ways of solving these simultaneous equations, one of which is to start by doing equation 1 squared plus equation 2 squared. If we do this looking at the left-hand sides, we square this side, so we get r squared times cos squared alpha, and squaring this one gives us r squared times sin squared alpha, and this must be equal to the sum of the right-hand side squared, so 3 squared plus 1 squared. We have a common factor of r squared on the left, and in the bracket we get cos squared alpha plus sin squared alpha. On the right we have 9 plus 1, which is 10. Cos squared alpha plus sin squared alpha we know is always equal to 1. This is a Pythagorean identity. So we get r squared is 10, and therefore r is the square root of 10. We can find alpha now by doing equation 2 divided by equation 1. For the left-hand sides we get r sin alpha divided by r cos alpha. And on the right-hand side we get 1 divided by 3. The r's will cancel, and sin alpha over cos alpha is tan alpha. So tan alpha is 1/3, and then alpha is the inverse tangent of 1/3, and this evaluates to give 18.4 degrees, correct to 3 significant figures. Finally, we can write 3 sin x plus cos x is identical to root 10 times the sine of x plus 18.4 degrees. We're going to use this in the next 3 examples.